Hi, I'm Tim Tyler, and this is a video about improving irrigation via watershed management. Water is a critically important nutrient for plants and animals. The world's water supplies are extremely unevenly distributed, and many plants and animals are in a near constant state of dehydration. So, interventions that favourably alter the distribution of water on the planet's landmasses could have a large positive impact on many forms of land-based life. The science and technology of managing this water is known as watershed management. The world's landmasses are divided up into a series of drainage basins by what are known as drainage divides. This happens as a result of erosion that has been caused by previous running water. To produce a more even water distribution over the available land, two areas need to be addressed. One is management of water within the drainage basins, and the other is changing the distribution of water between those basins. Some of the main technologies involved are dam creation, barrier elimination, hole drilling and siphon construction. The areas of most interest are where running water faces a choice about the path it takes while flowing downhill. Erosion tends to create valleys surrounding flowing water, but there will be some places where running water faces a choice and where relatively small interventions can make a big difference to the resulting fluid flow. This idea follows the principle of locating places where small actions can have large effects and then applying your energy at those points. Since humans have only done rather limited watershed management in the past, it is likely that there are still a considerable number of low-hanging fruit in this area. Dams can be created by piling up matter. Barriers can be eliminated by shifting them. Earth can be moved by using conventional techniques, and rock can be moved using explosives. If you imagine for a moment that you have a high ridge with water on one side of it and a lack of water on the other, perhaps because rain clouds are forced up by the ridge itself and so deposit their load of rain mostly on one side of it, then cutting a channel through the ridge might not be very practical. And if we represent the ridge by this piece of paper, so here is a ridge, and we imagine that we've got some water here on one side of it, and then you want to transfer the water across this drainage divide here to the other side, then cutting a big channel through the ridge might not be possible because of the sheer volume of material and the cost of creating such a channel. However, there are some alternatives involving siphons and drilling holes. So one possibility might be to drill a hole using a machine through the ridge and then pass water down a tube through the ridge and out the other side into a basin on the other side. And another possibility might be using a siphon. So again, imagine you've got some water here and you want it over here, then you could create a tube and use it as a siphon to transfer the water up and down the other side. And siphons work under gravity, so you don't need a pump to get the water from one side to the other. And then lastly, if the top of the ridge is not itself of uniform height, then there's some possibility of transferring water from one side of the ridge to the other side by allowing it just to run downhill. So imagine if we've got some water here and we want the water to wind up over here, then if you watch my finger will always constantly go downhill, imitating fluid flow. So here the water goes downhill, crosses over the ridge here, and continues downhill, and then winds up where the water is needed over here. So that's another way of getting water from one side of a drainage divide to another. If the divide is not itself of uniform height, the water can often cross over under gravity if it's channeled in the correct way. At drainage divides, these kind of techniques can be used to transfer water between drainage basins, from ones that are well stocked with water to other ones where water is scarce. Where water is diverted, so split, forked into two different possible directions, then ideally locks should be used, so the old flow can be restored periodically to service demand. One case where locks are useful is when a source is periodically used to top up a reservoir, but can also be used for other things. Water flow has been controlled in and around cities for a long time now. For example, in Bristol, the city where I currently lived, there's a 5-kilometre long engineered division of the River Avon to provide a floating harbour and the Bristol New Cut, which insulates the harbour from tide and storm waters. The waters are diverted by using locks, and this was all opened back in 1809. However, much less effort has been expended in the areas outside cities. To improve the planet's irrigation systems, I propose using publicly available map information which identifies current water flows and map elevation data to automatically calculate the cost-benefit ratio of various interventions which redistribute water so that it better irrigates the land. and then the top projects around the world, those that provide the most benefit for the least cost, should be embarked upon. Since water is so important to living things, improving irrigation via watershed management aimed at producing a more even distribution of the water seems like an important area to me. Enjoy.